Yeah, hi friends, I'm Shruti Shah. I'm going to talk about the principles of the network applications. When we develop a network app, the main idea behind it should be writing programs that can be run on different end systems and that can communicate over the network with each other. The main example we can think about is the web applications, where we have a couple of browsers and a server handles all the requests coming from the browser and gives them back a response, and these two entities are always communicating with each other over the network. Now we'll move on to the network application architectures. Before we start coding for any applications, we should have the broad architecture plan in mind first. Application architecture is very different from the network architectures, that is a 5-layer network architecture. From a developer's perspective, the network architecture is fixed, which provides a specific set of services to our applications, while the application architecture dictates how the application is structured over the various end systems. When we think about the application architecture, the two most prominent ones are client-server architecture and peer-to-peer architectures. So in client-server architectures, again we have a client and a server. Client requests, generally in client-server architectures, two clients do not directly communicate with each other. They do not communicate. They communicate actually via server. So server is the intermediate thing in between the two clients. Moreover, the server has a fixed IP address. Also, we can think of the examples like web, FTP, telnet, and mail. These are built upon the client-server architecture. The one problem here is the scalability. In fact, when we think of, we can take an example of social networking sites. Generally, they have many requests on the social networking sites. So we cannot have a single server that can handle all the requests. It becomes a problem. So we need to have some kind of data center. It simply consists of thousands and millions of servers that can handle many requests. And the data center is a very powerful virtual server. Next, now we move on to P2P architectures. In P2P architectures, there is no reliance on dedicated servers as such or data centers. Instead, the application exploits direct communication between the peers. Okay, so there is one peer to peer communication. We can have desktops, laptops, tablets, smartphones. So these devices can directly communicate with each other. Also, as there are no servers as such, so there are no service providers that own these peers. It's just the users, the users who own these devices. Also, this peer-to-peer architectures is suitable for traffic intensive applications. For example, like file sharing systems, like BitTorrent. Other example would be internet telephony like Skype. And the one more example is IPN, that is Kunken and PPStream. Main features of the P2P architectures is self-scalability. By the self-scalability, we mean that peers generally request file, and the other peers do kind of give them the file. So it is like a scalable. So peers can directly distribute files over the network to each other. Also, the other thing is it's very cost effective, as we do not need any server infrastructure in this. So it's very cost effective. That's it.
Hey everyone, this is Srilekha Chilupuri, and I'm going to be teaching you OSI model today. There are 7 layers in OSI model. The first one is application. The next one is presentation layer. Then it is session layer. Then it's transport layer. Then it's network layer. Then it's data link. And right at the end, it is physical. So, application layer basically provides Firefox, Chrome, email, and stuff like that. Presentation layer provides operating system and even ASCII characters. Session basically provides, or takes care of the conversation between 2 computers or 2 processes. Transport layer ensures that packets are delivered reliably from the source to the destination. Network layer makes sure that the best route for each data is sent across from the source to the destination. Data link layer checks for errors, and physical layer basically consists of cables, fiber optics, electric signals, and etc. Application layer basically uses protocols such as HTTP, FTP, and SMTP. Presentation layer basically has formats such as JPEG, GIF, and MPEG. Session layer basically, consists of apps like Apple Talk, Beanstalk. And then transport layer basically uses protocols such as TCP, UDP, and SPX. Network layer basically has keywords such as IP address, and then it also uses IPX router. Data link layer also uses certain keywords such as Ethernet and ATN switch. And then right at the end, we have physical layer, which uses stuff like hub, repeater. So this is basically the OSI model, and there's 7 layers. Now I'm going to teach you the application layer and an example of application layer and the 3 layers in application. Application layer looks like this. First of all, you have the presentation layer or session. In here, you have the web browser that resides, and then there is middleware or application server. An example of this is Tomcat server, and then we have the database, and This is the database server. An example for DB is MySQL, and then we have MongoDB, stuff like that. An example for this is AppStack. What is an AppStack? AppStack is basically an application stack, which is a set of applications. An example for this is LAMP. L for Linux, A for Apache, M for MySQL, and P for PHP. There are a lot of protocols in computer networks, and the most important ones are TCP, UDP, HTTP, SNMP, SMTP, and DNS. I'm going to be teaching you the first one, which is TCP IP. TCP is basically a transmission control protocol. In this, there is handshaking, and what sort of handshaking? It is three-way handshaking. So there are 3 steps involved in this. The first one is synchronization. The second step is synchronization and acknowledgement, and the last one is acknowledgement. Handshaking process basically alerts the client and the server, allowing them to prepare for the flow of packets or the onslaught of packets. As a result of this, the data transfer service is really reliable as compared to UDP protocol, which we're going to get to a little later. The connection is full duplex, which means that both the processes can send messages to each other over the connection at the same time. Another feature of TCP is that the communicating processes can rely on TCP to deliver all the data without any error and in proper order, unlike in UDP. An example of TCP is www, that is World Wide Web. The feature that TCP allows is to, basically to have a delay in sending packets from the source to the destination. The big drawback of TCP is that no checksums are allowed. What checksums are? Checksums are basically a count of the number of bits that are being sent across from the source to the destination, which helps to double check if the right number of bits has arrived at the destination or not. I'm going to be running through another protocol called UDP, and the full form of it is User Datagram Protocol. It's basically a lightweight and robust protocol that provides minimal services. Checksums are present in UDP, as a result of which the destination can double check if the right number of bits have arrived or not at the destination. No handshaking is present, which makes UDP less reliable as compared to TCP. UDP also has a disadvantage of providing unreliable data transfer service. There is no guarantee that the packets will reach the destination. Even if the packets do reach the destination, they might be completely out of order. UDP also does not include a congestion control mechanism, as a result of which the sending side of the UDP can pump data into network layer, which is beneath the presentation layer, at any rate that it pleases. Another property of UDP is that delays are allowed during transmission of packets from the source to the destination, unlike in TCP. Examples of UDP are media streaming and games. I'm going to teach you another protocol, and it's called HTTP, which is very important. The full form of it is Hypertext Transfer Protocol. HTTP is implemented in 2 programs, client and server. The client and server programs executing on different end systems talk to each other by exchanging HTTP messages. HTTP defines the structure of these messages and how client and server exchange the messages. I'm going to be reviewing some of the web terminology that is used, like web page, web client, web server. So what is a web page? It basically consists of a lot of objects. Any object is a file, such as HTML file or a JPEG file or a video clip that is addressable by a single URL. To show you how this works, let's assume this is the client, and this is the server. So the client is going to send across an HTTP request to the server for an object or any resource, and then the server is going to return, I would say, rather it replies to the client by sending it across an HTTP response. This is the actual working of client and server. HTTP is said to be a stateless protocol. The server sends requested files to clients without storing any state information about the client. If a client asks for the same object that it just asked for a couple of seconds ago, the server is going to send it again since it's already forgotten what it did earlier. Since HTTP server maintains no information about the clients, HTTP is said to be a stateless protocol. Now I'm going to teach you a little about cookies. A cookie is a plain text file with no logic on it. It is often desirable for a website to identify users, maybe because the server wishes to restrict user access. For this purpose, HTTP uses cookies. Cookies are stored on router and on satellites. Now I'm going to teach you a little about web caching. A web cache is also called a proxy server. It is a network entity that satisfies HTTP requests on behalf of the server. The web proxy has its own disk storage and keeps copies of the recently requested objects in its storage. This is the working of web proxy server. Let's assume this is the client, and this is a proxy server, and then this is the main server. We can also call it the origin server because it's the main server. So the client is first going to send across an HTTP request for an object to the proxy server. If the object is present in the data storage in it, it's going to return it immediately along HTTP response. If the object isn't present in it, it's going to right away send across an HTTP request to the main server. And then the main server looks for the object and it returns it to the proxy server along HTTP response, which it's going to send back again to the client along HTTP response. This is actually the working of web cache, proxy server, client, and origin server. Web caching has been displayed in the internet for two reasons. First, a web cache can substantially reduce the response time for a client request, especially when the bottleneck bandwidth between the client and the server is much less than the bottleneck bandwidth between the client and the cache. If there is high-speed connection between the client and cache, and if the cache has requested for an object, then the cache will be able to deliver the object rapidly to the client. Another reason that it's used is for in order to speed up internet surfing. Web caches can substantially reduce traffic on companies' access links to the internet. And web caches can substantially reduce web traffic in the internet as a whole even, thereby improving the performance for all of the applications on the internet. Another reason that web caching is used is to hide the IP address of the client computer so that it can serve anonymous. This is basically done for security reasons. Another interesting feature why web caching is used is to bypass security restrictions and filters. For example, work offices have blocked many applications like Facebook, MySpace. However, one can use proxy server to bypass these restrictions that the company puts ahead and access blocked websites easily. Another type of HTTP is HTTPS, which is basically for secure browsing. Now we're going to move on to another protocol. It's called SNMP, which is Simple Network Management Protocol. This basically monitors the network. It is a set of standards for network management that includes application layer protocol, database schema, and even data objects. It basically resolves the network to traps or committees. This is about it, and I'm going to just give you some information about hash table, even though it's not really relevant to protocols that I've taught you so far. But here it is. Hash table basically is a flat file that contains logic. So over to Shruti. Thank you so much.
Now I'm going to discuss about the email system, electronic mail system over the internet. Email is generally the asynchronous type of the communication medium. Now modern features in the email are that we can send the attachments with the messages, even the HTML text outputs or embedded photos and various kind of hyperlinks we can share through email. The three major components of the email systems are user agent, then the mail servers, and the SMTP protocol, that is the Simple Mail File Transfer Protocol. So the main architecture in this is we have kind of a mail servers here set up, and we have a small user agents. We have many such mail server, user agents, mail server and user agents. In mail server we do have a queue of messages and some mailbox. This mail servers communicate over SMTP protocol. Now the main idea is the user agents basically can read, reply, forward, save or compose messages like we do in normal day-to-day life. For examples, we have Microsoft Outlook and Apple Mail is also there. For example, now take if Alice writes a mail. So, and if she wants to send a mail, how this travels through the network. Alice composes her message, then her user agent sends the message to the mail server. This user agent, it sends it to the mail server, Alice. It goes in the outbox messaging queue, it stays there, and when Bob wants to read the messages, his user agent, kind of if Bob is here, it retrieves the messages from his mail server and then he can read his messages. The mail server is a very important entity over here. It is the core of the infrastructure. Each recipient like Alice and Bob have their own mailbox located in the mail server. Also the SMTP protocol, it is the principal application layer protocol for internet mail. It uses a reliable data transfer over the TCP to transfer the mail from sender's mail server to the recipient's mail server. Now the SMTP protocol has the two sides. One is the client, one is the server. When a mail server sends the mail to the other mail servers like this, when this sends this mail to this mail server, it acts as a client, okay? And when the other mail server kind of receives this mail server, it acts as a server. When it receives, when it sends, it acts as a client. When it receives, it acts as a server. Now, the most popular mail access protocols are POP3, IMAP, and HTTP. POP3 is post office protocol version 3. IMAP and HTTP. Now, what are these three? We'll talk about them. Now, post office version. In post office protocol, we generally do have 3 phases. First one is authorization. It's simple. Whenever we want to access our mailbox, we have to provide the username and password so that we can access our mailbox. That is the first step. Then the second phase is transaction. Here generally we can read our mail, delete our mail, or obtain any mail statistics like how many read messages or unread messages are there in a mailbox. And the second phase is update. As soon as the user quits, then the POP3 session ends. So then the mail server now delegates the messages that were marked for deletion. So whatever the user has marked for delete, the mail server can act on that and it deletes all the messages. So this was about POP protocol. Now we will discuss about IMAP. Now the main problem in the POP is you have to download the messages or kind of mail into on your local machine into a folder. So you cannot access this mail when you are, suppose you're traveling to other places, so you cannot access this. It's always stored on the local machine. You cannot access these mails on the other machines. So to overcome this, the POP protocol does not provide any means for users to access the remote folders. So IMAP, that is a mail access protocol, it provides us more features and overcomes this problem. IMAP server maintains a state information across the IMAP sessions. It also provides the commands to allow users to create folders and more messages from one folder to the another. It also permits the user agents to obtain the component of messages. For example, from the bold message, if I just want to read the header information, I can just read the headers. If I don't want to read the other stuff, what is the attachments and all, so I can just read the header information and keep it. This is very useful when we have a low bandwidth connection. So we can read only the stuff that is needed. So this was about the IMAP. And now the third thing is as we have POP3 and IMAP, we also have HTTP. Here in HTTP, basically a user agent is the browser. So whenever user communicates via the remote mailbox, the user can communicate to his mailbox over HTTP only. And when suppose for example, if Bob wants to access his mailbox, email message is sent over the Bob's mail server, from the Bob's mail server to the Bob's browser, only using the HTTP protocol rather than using IMAP and POP3. Also, if the sender, such as Alice, wants to send an email messages, the email message is sent from her browser to the mail server over the HTTP protocol. That's it. Hi, I'll now talk about the domain name service, that is, DNS. This is generally an internet directory service kind of. Basically, we identify any address by its host name or an IP address. So host name is kind of, for example, you can take www.yahoo.com. So we can address this, but we actually cannot get much of the information from this. So we also use IP address. It looks just like this, something. IP address looks like this. Now service provided by the DNS. So main task of the DNS is to translate the host name to its corresponding IP address. What is DNS? It is actually a database, distributed database that is implemented in the hierarchy of the DNS servers. It's also an application layer protocol that allows hosts to query the distributed database. The DNS servers which are there in this, these are basically a Unix system. DNS servers, they are just the Unix system that is running over the Berkeley Internet name domain, that is the bind software. Now DNS runs over the UDP and on the port number is 53, and it uses the port number 53. Now I can show you the actual working of the DNS thing. Suppose consider we have a user machine. We have the client side of the DNS application running here. DNS applications client side runs over this machine. Now we have a browser, right? There we simply request for some resources, for example, yahoo.com, like that. So and we also have a DNS server over here. So what the browser does, whenever a user enters some host name, it first needs to have an IP address so that it can establish a TCP connection. So what it does is it sends this it sends this URL to the user machine, the host name from the URL to the user machine. This in fact queries the DNS with this host name. The DNS server looks up for the IP address and then it returns a response, that is the IP address of the corresponding host name. This user machine returns the IP address again here, and finally as soon as this browser, as soon as it gets the IP address, it then establishes a TCP connection and then it can access that website. So this is the concept of the DNS. The main concept is it matches the host name to the IP address. That's it. Thank you.